Hello, I'm Camille Thompson, and I'll be a freshman next year at Washington University in St. Louis, where I'm hoping to become an architect focused on sustainable design. When I'm not studying, you can probably find me on the basketball court. Today we're going to be looking for climate clues buried in the glaciers of Alaska. We're also going to explore how important it is to have all of the data to get an accurate picture of what's really happening. Sometimes people in the media like to pick and choose climate data to fit the story that they want to tell. This can create a very misleading picture. Take my basketball stats, for example. In my last game, I struggled in the first half and only shot 2 for 10, 20%. In the second half, I got hot and shot 10 for 12, or 83%. It's important to look at the stats for the entire game to get an accurate picture of me as a basketball player. For the entire game, I went 12 for 22, or about 55%. Not bad. Keep that in mind as we move through this virtual field lab series. Always look at all of the data before drawing any conclusions. Let me pass this to Winski to introduce himself as well as the data from the glaciers in Alaska that we're going to analyze today.
Thanks, Mikhail. Today we're going to really get into the data, into the actual information contained in the ice core itself and what that can teach us. So if you remember, one of the goals of our entire research program here in Alaska is to understand the variability of climate in the past. We want to understand things like how precipitation, temperature, wind patterns, all of that have changed, both naturally, how they vary from year to year, just on their own, as well as how they vary and how they've changed since humans have started affecting the global climate system in a big way. So one of the big outstanding questions to scientists is, how is the water cycle? Things like evaporation, precipitation, the movement of moisture from one area to another. How do these processes change? We have a fairly good understanding of temperature. We know the physics pretty well. And that is, if you add greenhouse gases to the atmosphere, for instance, then the temperature on the Earth's surface will rise. But understanding precipitation is much, much harder. So that's one of the things that we're hoping to do in this project, is to use the ice core data to understand changes in precipitation. Specifically, since we started burning a lot of fossil fuels and altering the chemistry of the atmosphere, because we know that those activities have really changed so much across the entire global climate system. And as we continue to be altering the composition of the atmosphere, there's reason to believe that that will continue to amplify a lot of the changes that are occurring across the climate system. So we want to understand here in Alaska and sort of across the Arctic and North Pacific regions of the planet, how is the amount of snowfall changing? And how has that changed since we started burning fossil fuels? Before we actually start looking at the data from the ice core, I would like you to make a couple predictions, because this is what we all do as scientists. So why don't you go ahead and do this now, and in your notebooks, write down what you predict that coring into the glaciers on Mount Hunter will show since we started burning fossil fuels. Even better is if you could come up with not only a prediction, but a reason why. So say you think the amount of snowfall on Mount Hunter has done X because of, and then maybe fill that in with some different processes that you think might be important. So take a few moments to do that, and then we'll meet back shortly.
Thanks, Dom. That was great. Hi, everyone. I'm Camille Moore, and I'm currently getting my Master's of Science at Georgetown University in Environmental Metrology and Policy. One of the biggest challenges I face in my work is pulling a clear story from large data sets. Dom asked me to look at all the snowfall data to suggest the best use of statistics to understand the amount of snowfall on Mount Hunter that was gathered from the ice core data set. As Dom and his friends drilled deeper, the ice got older and older. The ice core they drilled in 2013 went down into ice that was formed over 1,000 years ago. That was a long time ago, which means that there's a lot of great data to analyze. This spreadsheet shows the amount of snow that fell each year on Mount Hunter in units of meters of water and snow. These units account for the fact that some snow can be light, fluffy, and mostly air, while other snow can be heavy, slushy, and mostly water. To get this number, scientists had to figure out how much water the snow or ice makes when it is melted. Remember at the beginning of this episode, Mikhail made the point that it's important to look at all of the data to get an accurate picture. Averaging the small pieces of a large data set in an unbiased way is a great way to pull an accurate picture from a large set of data. So what we're going to do today is analyze how much snow fell during the first 10 years of each century. Let's make a data table in your notebook to record our averages. We can title the table Snowfall during the first 10 years of each century. You can label the left-hand column the ending year of the decade we analyze, and the right-hand column will be labeled with average annual snowfall. We can also fill in the years that we will analyze starting with 2010 and going all the way back to 1310. So let's start by finding the average snowfall for the first 10 years of the current century. You'll probably need to grab a calculator for this. To find the average, we just add all of the individual years together. In this case, when we add all of them together, we get a total of 15.8 meters of water equivalent snow. That 15.8 meters fell over 10 years, so we just take the 15.8 meters and divide by 10 years. So if we do this, we get an average of 1.58 meters of water falling in the form of snow each year. Let's put that number in your data table, then let's move on to the next set of data. Now let's try a second example. Let's look at the first 10 years starting in 1900. Let's do the same thing and add up all of the snowfall for the first 10 years. So once we have that total, simply divide by the 10 years. For this decade, it looks like there is an average of about 0.756 meters of water falling in the form of snow each year. The two answers we computed look very different to me, but remember what Mikhail pointed out in the beginning with her basketball statistics. It is always really important to look at all of the data. Since we have almost 1,000 years of data, let's pause the video and do some more calculations to get a really complete picture. Here are all of the data sets for the first 10 years of each century. Take some time, calculate the average of each data set, then add all of the averages to your data table. When you are done, hit play again, and we will try to determine if there really has been any significant changes in the amount of snow falling on Mount Hunter since humans first began burning fossil fuels.
Okay, welcome back. So hopefully by now you've all had a chance to go through each of these data tables and to calculate the averages during the first decade in each century to figure out how much snow fell during each of those time periods. And I'll fill in what I got here on my table in this notebook on your screen. And you can see that it's changed a lot. You know, we're getting very small amounts of snow in meters of water equivalent in the early parts of this record compared to during present day when we're having over 1.5 meters of snowfall. An easier way to sort of visualize and digest data like this, I find, is to put it on a graph. It's a really powerful way to tell a story using the data. So why don't, in your notebooks, you set up a graph, and on the x-axis, please make that time, and you can label each different century in accordance with the first column in your data tables. And on the y-axis, I would suggest labeling that in terms of the average annual snowfall in meters of water, just like in your table. And then what you can do once you have that set up is you can mark each of these individual data points on your graph. So take a moment and fill out your graph using the data that you've assembled in your table, and then we'll meet back shortly. Okay, welcome back. So by now, hopefully you've had a chance to construct and fill in this graph of snowfall from Mount Hunter over time. And now I'll start to fill in mine to give you a sense of what the data show. So back in the 13 and 1400s, in the early part of the record, we have comparatively low snowfalls, around 0.3 or 0.4 meters of water equivalent snowfall per year on average, as opposed to in the 2000s, we have over 1.5 meters of snowfall. And if you fill that in, you can actually see some interesting structure in the record itself. One thing we can do to simplify this further and to maybe tell a story is to add some trend lines. And just before we do that, I want to just take note of the time that we started burning fossil fuels, since that's one of the things we were setting out to try and test here, to see whether the onset of fossil fuel burning and the increase in the amount of greenhouse gases in the atmosphere has had an impact on the amount of snowfall in Alaska. So I'm adding the smokestack here on my graph. You can add some sort of note here onto yours about near the turn of the 20th century, around late 1800s, early 1900s, when we really started to pump out a lot of greenhouse gases into the atmosphere from fossil fuel burning. So I'm going to add a couple trend lines into my graph, and each of these trend lines you'll notice has a different slope, and you can add your own based on your own interpretation. Before we wrap up, I would like to give all of you a chance to really think about the data yourselves. So write down 2 bullet points about 2 things that you notice. So what are 2 things that you notice, 2 features that jump out at you in the data? And then 1 thing that you wonder. So one maybe further hypothesis that you have now that you have some more information about this data. In your notebooks, again, 2 things that you notice and 1 thing that you wonder. And then we'll meet right back after you've had a chance to do that to wrap up. Hi everybody, welcome back. So hopefully now you've had a chance to think about the data a little and write in your notebooks 2 things that you've noticed and 1 thing that you wonder. So now to wrap up, I want us to go back and think about our original question, the reason why we went to Alaska to drill this ice core in the first place. And that's to answer this question of how much has snowfall changed since we've begun burning fossil fuels. And rather than answer this question for you myself, I'd like all of you to think about it based on the observations that you've made by looking at this data. So think about how much has the amount of snowfall changed since we have begun burning fossil fuels. And in your notebooks, write down the data suggests that since we started burning fossil fuels that, and then fill that in with your interpretation. What do you think this data shows in terms of the behavior of snowfall in Mount Hunter since we've begun burning fossil fuels? And then, in addition to that, say what the evidence is that supports your interpretation of the data. Okay. Hi, everybody. Welcome back. And when we meet back next time, we're going to bring in more data to help further this interpretation. So right now, you might have drawn some conclusions about snowfall, some pretty striking and potentially surprising ones. But like Mikhail said, it's really critical to look at a whole variety of data as much as you can before coming to your final conclusion. So when we come back next week, we're going to look at the snow melt data in addition to the snowfall data. So join us in the next episode as we add in the snow melting data from Mount Hunter, and we wrap all of this up into our interpretations of what we think is happening to cause these big changes in Alaska. Thank you.